To begin the search for the creature known variously as the Yeti, the Sasquatch, or the Almas, we must first strip away the tabloid sensationalism and the blurry photos of men in gorilla suits. We have to treat this subject with the cold, clinical rigor of a paleontologist. The question is not, do monsters exist? The question is, did a giant bipedal primate exist alongside early humans? And the answer to that question is an absolute, scientifically verifiable yes. The snowman is not a ghost. It is a memory, and the physical proof of its existence sits right now in the drawers of museums in London, Beijing, and San Diego. The story of the real giant begins not in a snowy mountain pass, but in a dusty, traditional medicine shop in Hong Kong in 1935. A German paleoanthropologist named Ralph von Königswald was browsing through jars of dragon bones, fossils ground up and sold for Chinese traditional medicine, when he spotted something that made his heart stop. It was a molar. But it wasn't a dragon's tooth, and it wasn't human. It was a primate molar, but it was massive, roughly twice the size of a modern gorilla's tooth. Von Königswald realized he was holding the remains of an unknown species. He named it Gigantopithecus blacki. Since then, scientists have recovered thousands of teeth and 4 partial jawbones from caves in southern China, Vietnam, and Thailand. By applying the laws of allometry, the biological study of how body part sizes relate to overall body size, we have reconstructed the owner of these teeth. The results are terrifying. Gigantopithecus stood nearly 3 meters, 10 feet tall, and weighed up to 600 kilograms, 1,300 pounds. To put that in perspective, a large male silverback gorilla weighs about 180 kilograms. Gigantopithecus could have snapped a gorilla's spine with one hand. This was the real King Kong. But unlike the movie monster, this animal was not a solitary freak of nature. It was a successful species that dominated the bamboo forests of Southeast Asia for nearly 2 million years. But the most chilling fact about Gigantopithecus is its timeline. Radioactive dating of the cave sediments where the fossils were found reveals that this giant ape did not go extinct until approximately 100,000 years ago. This date is crucial because it overlaps with the migration of Homo erectus, our direct ancestors, into Asia. This means that early humans and giant 10-foot-tall apes shared the same forests, drank from the same rivers, and likely competed for the same caves. The implications of this coexistence are profound for the study of folklore. Anthropologists suggest that the universal human myth of the wild man, the hairy, silent giant who watches from the trees, is not an invention of the imagination. It is a species memory. Just as we have an instinctive evolutionary fear of snakes and large cats because they hunted us for millions of years, our culture retains the traumatic memory of living in the shadow of Gigantopithecus. When a Sherpa in the Himalayas or a hunter in the Pacific Northwest describes a Sasquatch, they are describing the biological reality of Gigantopithecus with uncanny accuracy. The massive, barrel-shaped chest, the lack of a neck, the head sits directly on the shoulders due to massive trapezius muscles needed to support a heavy jaw, and the bipedal or semi-bipedal gait. However, we must address the biology of its movement. Could such a massive animal walk on 2 legs? Skeptics argue that the square cube law would force an animal of that weight to be a knuckle walker, like a gorilla. But recent analysis of the jaw structure suggests that the head was balanced on top of the spine, similar to a human, rather than hanging forward like a chimp. This foramen magnum alignment is a strong indicator of upright posture. While Gigantopithecus was likely too heavy to run like a human, It probably stood on two legs to reach high bamboo or to intimidate predators, a behavior that, when witnessed by a 4-foot-tall early human, would have been etched into our collective nightmares forever. The snowman was real. He was an ape, he was a vegetarian, and he was our neighbor. But the tragedy of Gigantopithecus was not a war with humans. It was a war with the planet itself. The extinction of the real-life giants is a textbook case of what biologists call the specialist's trap. Chemical analysis of the isotopes in Gigantopithecus' teeth tells us that they were strict vegetarians with a massive dependence on bamboo and fibrous forest fruits. They were biological machines built for a specific environment, the dense, warm, subtropical canopy. But around 100,000 years ago, the Pleistocene climate began to swing violently. The global temperature dropped, the rainfall patterns shifted, and the great forests of Asia began to recede, replaced by vast, dry savannas. This was the death sentence. A 600-kilogram animal requires a caloric intake that is astronomical. When the high-calorie fruits and bamboo disappeared, Gigantopithecus was physically unable to adapt. It was too heavy to travel long distances across the open plains to find new food sources, and its digestive system was not evolved to process the low-energy grass of the savanna. Meanwhile, their smaller neighbors, Homo erectus and later Homo sapiens, were the ultimate generalists. We ate meat, tubers, insects, and cooked food, which released more calories with less digestion. We flourished in the changing world, while the giants starved in the shrinking patches of forest. The fossil record suggests that as the lowlands dried up, the last populations of Gigantopithecus retreated higher into the mountains, into the karst caves of the limestone plateaus, seeking the last remnants of the bamboo ecosystem. This scientific fact aligns hauntingly with the Yeti legends. The wild man is always described as living in the high, inaccessible peaks, the final refuge of a species hiding from a world that had become hostile to its existence. They didn't hide because they were magical. They hid because they were dying. This brings us to the greatest forensic mystery of the North American continent: the Sasquatch. If Gigantopithecus is the source of the Yeti legends in Asia, can it also explain Bigfoot in Oregon? This is where the Beringia paradox shatters the theory. For a giant ape to get from China to Canada, it would have had to cross the Bering Land Bridge, a frozen tundra steppe that connected Siberia to Alaska during the Ice Ages. Mammoths crossed it, humans crossed it, bison crossed it, but there is no evidence that a tropical, bamboo-eating ape could survive a 1,000-mile trek across a frozen wasteland with no trees. Furthermore, the fossil record in the Americas is deafeningly silent. We have dug up tens of thousands of megafauna bones in North America. Saber-toothed cats, short-faced bears, dire wolves, American lions. If a breeding population of giant apes lived here for 15,000 years, we would have found a tooth, a jaw, or a femur in a tar pit or a riverbed. The soil conditions in the Pacific Northwest are acidic, yes, but they are not magic. They preserve other animals. The complete absence of physical evidence suggests that the Sasquatch is not a biological immigrant from Asia. So, if the physical remains are missing, what are people seeing? In 2014, geneticist Brian Sykes from the University of Oxford conducted the most comprehensive DNA study ever performed on Yeti hair samples collected from museums and hunters across the Himalayas and North America. The cryptozoology community held its breath. The results were a cold shower of reality. The samples were not from an unknown primate. They were from horses, raccoons, cows, and humans. But two samples from the Himalayas were different. They matched the DNA of an ancient Paleolithic polar bear, a subspecies thought to be extinct for 40,000 years. This suggests that the Yeti might biologically be a high-altitude hybrid bear, a creature that displays aggressive behavior and, crucially, can stand on its hind legs. When a bear stands up, the anatomical resemblance to a human is terrifyingly specific. Bears are plantigrade. They walk flat on their feet, just like us, unlike dogs or cats that walk on their toes. A skinned bear carcass looks so disturbingly like a human body that police officers are often trained to tell the difference to avoid false murder investigations. In the low light of a forest, a standing bear has broad shoulders, arms that hang at its sides, and forward-facing eyes. The Sasquatch sightings are likely a psychological phenomenon known as pareidolia, the brain's desperate attempt to recognize a human shape in the chaos of nature, triggered by encounters with known predators like the black bear or the brown bear. The snowman is real, but he isn't an ape. He is a bear that our brain tries to turn into a man because we are biologically programmed to fear the other that looks like us but isn't us. The giant ape Gigantopithecus is gone, returned to the dust of the Chinese caves. But the shadow he cast on the human psyche is so long that we still see him in every shadow of the modern woods. However, there is one final haunting scientific possibility that keeps the search alive. If the Yeti is not a giant ape like Gigantopithecus, could it be a relic population of an archaic human species? For decades, this was dismissed as fantasy. Then, in 2003, on the island of Flores in Indonesia, scientists found Homo floresiensis, the hobbit. These were tiny 3-foot-tall humans who hunted pygmy elephants and made tools. Crucially, they lived until very recently, perhaps as late as 50,000 years ago, overlapping with modern humans. Then, in 2019, in the Philippines, we found Homo luzonensis. The family tree is not a straight line, it is a bush, and we are just the last branch left. But the most significant discovery for the snowman theory lies in a cold cave in Siberia, the Denisovans. In 2010, geneticists sequenced DNA from a tiny finger bone found in the Denisova cave in the Altai Mountains. They discovered a completely new species of human, distinct from us and Neanderthals. But here is the shock. The Denisovans didn't just live in Siberia, they lived in Tibet. In 2019, a massive jawbone found on the Tibetan plateau, the roof of the world, was identified as Denisovan. This proves that a robust, archaic human species capable of surviving in extreme cold and high altitudes lived in the exact same region where the Yeti legends originate. Furthermore, modern Sherpas share a specific gene variant, EPAS1, that allows them to breathe easily at high altitudes, a gene they inherited directly from mating with Denisovans. This changes the wild man from a monster into a memory. The Almas of Mongolia, or the Yeti of Tibet, might not be descriptions of an ape, but oral traditions preserving the memory of our encounters with the Denisovans, a large, heavy-browed, fur-clad human species that retreated into the mountains. As Homo sapiens expanded, we didn't hunt a monster. We outlasted our cousins. The uncanny valley. That feeling of revulsion we get when looking at something that looks almost human but not quite, might be an evolutionary alarm system developed during the thousands of years we shared this planet with other hominids. We are hardwired to fear the other who walks on two legs. Ultimately, the science tells us that the Earth is a lonely place today. For millions of years, there were always multiple types of people. Gigantopithecus, Neanderthals, Denisovans, hobbits, and us. It was a Lord of the Rings world, but one by one, the others winked out due to climate change, competition, or assimilation. The disappearance of the snowman is not a mystery of cryptozoology. It is the final chapter of anthropology. The reason we keep looking for him, scanning the tree lines of the Pacific Northwest and the peaks of the Himalayas, is perhaps because we miss them. We are suffering from a species-level loneliness. We are the last survivors of a great primate family, scanning the empty woods, hoping that we are not the only ones left who can speak, think, and walk upright. But the silence from the forest is the answer. The giants are gone, and we are alone. To finalize the forensic audit of the Sasquatch phenomenon, we must confront the holy grail of cryptozoology, the 1967 Patterson-Gimlin film. For over 50 years, believers have pointed to this grainy, shaky footage of a hairy figure walking through a Californian creek bed as definitive proof. They claim, you couldn't make a suit that good in the 60s. Science begs to differ. Modern biomechanical analysis, utilizing stabilization software and gait modeling, reveals the truth hidden in the muscles. When a real, biological entity weighing 800 pounds takes a step, a phenomenon called soft tissue resonance occurs. Massive muscles don't just sit there. They ripple, jiggle, and compress with every impact. A quadriceps muscle capable of lifting a giant leg contracts visibly. But looking at Patty, the creature in the film, under high-resolution enhancement, the muscles behave like foam padding. There is no independent movement of the glutes or the thighs. The fur does not ripple with the wind or impact. It moves as a solid, matted sheet. This is the hallmark of a top-down construction, fur glued to a static base, not growing out of a dynamic skin. Furthermore, let's talk about the gait, the way it walks. Anthropologists call it a compliant gait. The creature walks with bent knees and a swinging torso. For decades, proponents said, humans don't walk like that. Actually, they do. It is exactly how a human walks when they are wearing massive, heavy, prosthetic feet, like swim fins or clown shoes, and trying to maintain balance on uneven river rocks. The bent knee lowers the center of gravity to prevent tripping. In 2004, researchers successfully replicated the impossible walk simply by weighing down a human subject with a heavy suit and asking them to walk fast over rough terrain. The body naturally adopts the Sasquatch walk to compensate for the added mass and the lack of ankle flexibility. The Patterson film is not a capture of an unknown primate. It is a masterclass in human adaptability to a restrictive costume. But if the video is fake, what about the sounds? The so-called Sierra sounds, recorded in the 1970s, feature guttural screaming, whistling, and what sounds like samurai chatter, a strange, articulate language. Bioacoustics, the physics of animal vocalization, can debunk this instantly. The range of sounds a primate can make is dictated by the position of the larynx, voice box, and the shape of the hyoid bone. Great apes, chimps, gorillas, and theoretically Gigantopithecus have a high larynx. This allows them to breathe and eat at the same time, but it physically prevents them from producing the range of vowel sounds, A, E, I, O, U, necessary for articulate chatter. They can roar, hoot, and grunt, but they cannot speak language. Only humans have a descended larynx. Therefore, the samurai chatter recordings present a biological paradox. If it is an ape, it physically cannot make those sounds. If it is making those sounds, it must have a human vocal tract. The volume, often cited as too loud for a human is also a misunderstanding of physics. A human screaming into a parabolic microphone in a canyon, which acts as a natural amplifier, can easily register 120 decibels. The Sierra sounds are not the calls of a monster. They are either the hoaxes of men or the misidentified screams of a mountain lion. Cougar. A female cougar in heat produces a sound that is famously described as a woman being murdered. It is a high-pitched, oscillating scream that triggers a primal panic response in humans. In the dark, a cougar's scream doesn't sound like a cat, it sounds like a demon. Finally, we must address the fear frequency. Many witnesses report a sensation of irrational, paralyzing dread before they even see the creature. This is not psychic power, it is likely infrasound. Infrasound is a sound wave with a frequency below 20 Hz, too low for human ears to hear, but strong enough for the body to feel. Tigers use infrasound, 18 Hz, to stun prey. Their roar literally vibrates the internal organs of their victims, causing paralysis and nausea. But geological events produce it too. The friction of tectonic plates, rushing water in deep underground rivers, or even wind vibrating through specific canyon formations can generate standing waves of infrasound. A hiker walking through a haunted forest might be walking through a geological infrasound zone. His eyes start to vibrate, a known side effect of 18 Hz, causing peripheral hallucinations. His stomach turns. His brain, searching for a cause for this fear, hallucinates a predator. He sees a shadow turn into a monster. He isn't seeing a Bigfoot, he is hearing the earth, and his brain is telling him to run. The wild man is a ghost in the machine of our own neurology.